We're told the height of a projectile if it's traveled a horizontal distance of x feet is given by this equation. Okay, so keep in mind what this means. H is the height, so that's how tall it is. X is how far it's moved away from where it was shot. And we want to use this function to answer questions rounding to 2 decimal places. Okay, so the first one, part A, at what horizontal distance from the firing point is the height a maximum? Maximum. This is a quadratic with a negative coefficient in front, so our shape is going to be a parabola that opens down. Now, I can find the maximum from the vertex, and the vertex, I've got that formula, negative b over 2a, but I recognize that I've got some not so pretty numbers here. So maybe I'm going to do this one by graphing. It's an option. You could definitely do it algebraically if we wanted to. Okay, now be careful with typing this in. It's a negative 32x squared, and then that gets divided by a 60 squared. Let me get that parentheses out of my exponent. Then we're going to add in x. Oops. Add in x. And then also add in 50. Okay, so maximum, looking for the vertex. I've got to have a good window. So when I go to my window screen, looks like I was on the standard screen to stop last time. X is the horizontal distance. Well, that's not going to be negative. It's going to go from 0 to somewhere. How far? I don't know. I'm going to take a guess. I'm going to say 100. Maybe it goes 100 feet. Maybe it's less than that. Maybe it's more. I don't know. And then I'm going to change my scale to be 10 to compensate for my number of tick marks. Now what about my y's? Y represents the height. Okay, so I'm going to have a height of at least 0. I'm not going to go into the ground. How high does this go? Again, I don't know. I'm going to say 500 feet is my guess. I could have very well picked a really good window, or I could have picked a terrible window. I'm not going to know until I graph. Well, it's not bad, but it's not great. Okay, so I can see a little bit of the parabolic shape where it's starting to come down. But I haven't gone out far enough to where this is going to hit the ground, and I'm guessing that's going to come up later, because often that does. But I also have a lot of wasted space here. So that means I've gone up too high. Now I can hit trace to kind of give myself a feel. Looks like they're hovering in the 70s. So I'm going to make the height just go up to 100. That should give me enough space. Now, I should have enough to get my information for this first problem because it's dealing with the maximum and I can see the vertex. So this is a good enough graph to answer part A at least. So for my work, I'm going to show the graph that I have. I need to find that vertex. So into my menu, option number 4, move to the left, to the right, and where the vertex is, and then as close as we can. Okay, now we're told to round. So this is approximately 2 decimal places. So for the x, I'm getting 56.25, and the y, 78.125 would round to 1.3. Now how do I answer the question? At what horizontal distance is the height a max? It's not asking for the height. It's asking for the horizontal distance, and that is our x value. So that's this number. So this would be 56.25, and that's measured in feet. Okay, now part B. What is the maximum height? Now they want the y value, and we've already done the work. It's 78.13 feet when we round. Okay, now what about these other questions? Part C. When the height of the projectile is 30 feet above the ground, how far has it traveled horizontally? This is telling me the height. So graphically, what I want to do is compare that to a height of 30. So I'm going to put that on my y2. Okay, now I can see the two graphs, but I can't tell where they hit each other. I haven't gone out far enough. And I want to know what happens when it's exactly 30 feet above the ground. So I need to adjust my window, which means I need to come farther this way. That's changing the X max. I had it at 100. Oh, let's just go to 200. Let's see what happens there. Aha, now I can see it. So when I look at the graph, here's my new picture that I'm using. This is the point that I want, the intersection. So I'll use option number 5 on that calc menu. Again, I'm going to approximate. This is about 129.83, and of course the y value is 30. Now which one do I want? Traveled horizontally. Again, that's the x value. So this is 129.83 feet after our rounding. Okay, the last one, how far has it traveled horizontally? So again, that's asking for the x when it hits the ground. Okay, so if I look at this picture, I don't need my other graph of 30 anymore. I'm going to take that off. Now I can see when it hits the ground, that's right when it's going to hit my axis. Okay, now because of the feature on the calculator, I'm going to go into the window and make my y value a little bit negative because I need to give it boundaries. Move to the left, move to the right, so I need that room. And this is done by using option number 2, 0. So I need to be to the left of my x-intercept, and then to the right of the x-intercept, and then as close as I can. And this one looks like I don't even need to round, 150, 0, so this is 150 feet. Now again, it's where we hit the ground, so that's right here where the height is going to be 0. We could have done C and D by hand. It's an equation we could do, but notice how nasty it would be. We need to know when the height is 30. So that would be solving the equation 30 equals negative 32x squared over 60 squared plus x plus 50. That's a quadratic equation. I'm sure that's not going to factor. I would have to use quadratic formula, and the a value is negative 32 over 60 squared. That's not very pretty. It would be very similar for part D because when it hits the ground, the height is now 0. But we'd still have that same mess over on the other side of the equation, particularly with that a value being negative 32 over 60 squared. So here graphically is probably the best approach.